Let's do some more tricks. I'd like to evaluate this limit. What's preventing me from using the direct substitution property? The x squared in the denominator, right? Because this function is not defined where? At x equals 0, which is precisely my limiting value. So we need to have something happen. I would like to cancel that x squared out of the denominator, right? I would like to divide it out somehow. We can't just wish it away, right? So let's try this trick. We've got an x squared in the numerator. Let's try to get it out of the square root somehow. Can I just pull it out? Okay. Let's put this to bed right away. Does this equal this? No, it does not. You cannot distribute a square root over what operation? What operation is that? Addition. Can you distribute a square root over addition? No. All right. So my problem still remains the same, though. I'd like to somehow use that x squared in the numerator to cancel with the x squared in the denominator, if I can. Let's try this. Okay. One way to get rid of radicals in a place is to multiply by the conjugate if it's a binomial. Okay. So what am I going to do? I'm going to take this expression here. Let me write it down here. The limit as x approaches 0, I've got to keep writing that limit, okay, of x squared plus 9 minus 3 all over x squared, and I'm going to go ahead and multiply this by x squared plus 9 square rooted plus 3 all over the square root of x squared plus 9 plus 3. Folks, am I allowed to just multiply an expression by any number I want? So I wanted to multiply the numerator by the conjugate of this expression. Notice that the conjugate is the exact same binomial, but the sign of the binomial changed. So if I have the expression a plus b, what's its conjugate? A minus b. It doesn't matter what a is, it doesn't matter what b is. To take the conjugate, you just change the sign of the binomial. Okay? So the trick that we're using is we want to multiply this expression right here by its conjugate. We'll see why that works in just a second. But I can't just multiply an expression by any old number. I can only ever multiply it by what? 1. Somebody once told me that most of math is adding 0 and multiplying by 1. I agree. Almost all the tricks we do are multiplying by 1 or adding 0 in some clever way that gets us where we're going. Okay? So this is just the number what right here? 1. Okay. Okay. So I'm going to go off to the side and just compute this part right here. I'm going to do this numerator product, x squared plus 9 minus 3, and I'm going to multiply it by the square root of x squared plus 9 plus 3. All right, I'm going to do this once slowly. I will usually FOIL this out in my head. Okay? So, how do you FOIL something? I don't remember the acronym. We're going to multiply this times this. Okay? So we do the square root of x squared plus 9 times the square root of x squared plus 9. True? Okay. Then we will do, I think we called it the outers. Okay. So then we'll do plus 3 times the square root of x squared plus 9. Then we will do the inners. What's the inners? Minus 3 square root of x squared plus 9. Then we will do the last, and we will get minus 3 times 3. Okay. Are there any questions on this? Any questions, folks? All right. Why on earth did I do this? I wanted to get rid of the square root. What is the square root of something times the square root of that same expression? It is just that expression. So this leaves me with x squared plus 9 right there for simplifying this expression. Any questions on that? Okay. Now, Why does multiplying by the conjugate just not make the problem more complicated? What happens to my outers and inners? They cancel. They reduce. They add out, right? Will that always happen? Yeah. When you multiply by a conjugate, it will always happen. That's why we multiply by the conjugate. That's why we do this trick, is we get rid of the square roots if there are any, but we don't make things more complicated because the outers and inners always cancel. Why do they always cancel? Because they will always have the opposite sign. Why will they always have the opposite sign? Because they're conjugates. And we get this right here, which is -9. That's for this term right here. Okay? So I will usually just do that in my head, folks. Okay? Why? Because it works the same way every time. So I don't even actually think about multiplying it out. I just say, okay, it gives me that expression minus the product of those two. So let's do it. Oops. There we go. So when I multiply by the conjugate, what do I get? In the numerator, I get the limit as x approaches 0 of x squared plus 9 minus 9. That's what we just showed. We just took some time to show that. Okay. Any questions on that? Now, folks, it breaks my heart because some people get so excited about multiplying by the conjugate, they just drop the denominator altogether. I can't tell you how many times people, they're doing all the correct work and then they just forget the denominator. Okay? Don't forget it. I don't know how to say that any other way. A fraction needs a denominator. Okay? So this leaves me with then x squared times the square root of x squared plus 9 plus 3. Okay, and I'm not going to worry. I could distribute that x squared if I wanted to, but having done this, I'm not going to distribute because it doesn't help me. We're left with, though, just the limit as x approaches 0. Here I'm going to run out of room, so I'd like to just write that that's going to be 1 over the square root of x squared plus 9 plus 3. What happened? First of all, the plus 9 and minus 9 added out, right? So that left me with x squared over x squared times this expression. But then the x squareds divide out, right? So I get 1 over just that expression. Now, what do we got? We've got a function that involves, it's not really a rational function because technically rational functions can't have square roots, but it's a root function that looks like a rational function, right? It is, let me just say it, I'm going to start using this word, we'll define it later. It is continuous everywhere it's defined. It's well behaved everywhere it's defined. Is 0 in the domain of this expression? If I plug in a 0, do I violate any rules of math? No. So let's go ahead now and apply the direct substitution property. Where did my limit sign go? Away. I stopped writing it because I did what? I applied the direct substitution property. Folks, did you write the limit every time up until then? All right. We end up with, once everything clears, 1/6. I do not think that there's a way you could, well, there are ways. But generally, I don't think you would look at this problem and ascertain that that's what the limit is. And I think you'd even have a hard time doing the plug-in numbers, right? Unless you're very good at spotting the decimal equivalent of 1/6, I think you'd have a really hard time even using that table of values approach. Any questions on that trick?